Hello, my name is Lim Wei Chen. We are going to design the arithmetic logic unit that stands for ALU that is a part of the reduced instruction set architecture, which is RISC-V. In our ALU design, it will consist of multiplexer, arithmetic unit, and register. I will talk about the 4-1 multiplexer. A 1-bit 4-1 multiplexer has two control signals and 4 inputs. The 4 inputs I0, I1, I2, I3 will connect to an AND gates respectively. For the control signal, S0 will connect to the second and fourth AND gates, and not S0 will connect to the first and third AND gates. For S1 will connect to the opposite of the S0 connected. Finally, all the output from the 4 AND gates will connect to an OR gate. After the gate is connected, we need to run the circuit. If it doesn't have any problem, we will press the file and press create or update. Then we press the create symbol files for current file to create the 4-1 multiplexer gates and save it. To build a 4-bit 4-1 multiplexer, we need to insert the block symbol of the 1-bit 4-1 multiplexer that we made previously and connect to the circuit, which have 5 inputs. We will connect the I03 to I33 respectively and S0 to the first multiplexer. Continue the following step with the change of the input to I02 to I32 and S11 to the last multiplexer. The most important step is to label the bus line of the inputs correctly, and the outputs will be Y3, Y2, Y1 and Y0 respectively. We will get an output of Y3 to 0. We will do the same step and create the symbol for the file 4-bit 4 times 1 multiplexer.
Hi, I'm Kamalia Sofia. I'll be showing you how to create an arithmetic unit to be able to perform additions and subtraction for our 4-bit data input. A full adder consists 2 data inputs, A and B, with a carry input. This produces 2 bit outputs that are carry out and sum. Based on the truth table of a full adder, we can get its logic expression. C out is A and B, or A and C, or B and C, while sum is A exclusive OR, B exclusive OR, C. We can proceed with the same method previously with the multiplexer by exporting this to a block diagram. We can still create a 4-bit adder and a 4-bit subtractor separately, however, it will lead to using more logic gates. We create a 4-bit adder subtractor for a lesser logic gate. Create a new block diagram and click on the symbol icon. Then under project, we will see our symbol design for full adder. Add 4 full adders in our circuit. Since our data input A has 4 bit, we will name it as A3 to 0. Create a bus line connecting to input A in each full adder and name each line A0 till A3. For our 4-bit B inputs, we are connecting each of it with a carry-in input through the exclusive OR gate. So when carry-in is 0, this ALU performs addition between A and B. If it's 1, subtraction is performed. Connect the outputs from each exclusive OR gate to the full adder at input B and each adder. Then connect the C out from the first adder to the second adder. Do the same with the next C out, that is C1, and connect every sum to S3 to 0 using the bus line. But we can ignore the final bit carry out signal in the adder. Lastly, export this block to a block symbol also.
Hi, my name is Gansun Tek. Now let's look how to design for a register. We need to have 3 input, which are D3 to 0. Next is for clock and reset. Because of we have 4-bit input, so we need to have 4 D flip-flop that we need to use in this register. We connect all the input D into D flip-flop by using a bus line and label all the line with their respective number, but all the clock and reset are connected together with their respective circuit into the flip-flop. We can connect all the output from the flip-flop together in a bus line and label it as Q3, Q2, Q1 and Q0. We combine them with an output 3 to 0. We export this to a block symbol also. We can combine all of the things together to build a ALU design. So now we will try to run our waveform. I already analysis and synthesis it. Now we can go to file and we press new and we choose this university program VWF and we click. Then we can right click and choose nodal finder and list. So these all our inputs and outputs. Then press OK. You can look at here. So these are our all input and output here. These all I already put the value in. Now we try to run it. Here are the output for the ALU. For the input, he will come out this output. So when the reset is 0, so there is nothing happen. So you can see here is 0, 0. So when the reset is 1, it will got a reaction happen and it is work with the clock. When the clock is at the positive edge, so it will got the value. So when the A selector is 0, 1, so which means is choose A1, so which is 1, 1, 0, 0. And we see for the selector B is also 0, 1, so we also choose for B1, which is 0, 1, 1, 0. So now we see for the ALU OP. So when the ALU OP, when it's 0, he will add the value. When it is 1, he will subtract the value. So here is 1, so he will subtract the value. Which is A subtract B. So 1, 1, 0, 0 subtract 1, 0, 0, 1, he will get 0, 1, 1, 0. So that's all for our group present about the ALU design. Thank you.